Hello, today I'm going to solve a microwave matching network example using a new software called Kitab, which is designed by a student at Princess Sumaya University for Technology. The software makes solving problem much more flexible and easier. Now we are going to solve the problem, which is find the matching network for a load impedance ZL equal 15 plus J30. Before we start solving the problem, we have to be concerned about the following important notes. 1. Red circles represent the constant resistance circles and the blue circles represent the constant conductance circles. 2. If we move on a constant resistance circle in direction of a clockwise, then we have to add a series inductor. However, if we move on a constant resistance circle in direction of anti-clockwise, then we have to add a series capacitor. 3. If we move in a constant conductance circle in the direction of a clockwise, then we have to add a parallel capacitor. However, if we move on a constant conductance circle in the direction of anti-clockwise, then we have to add a parallel inductor. Now start solving the problem. First of all, we have to find the normalized impedance ZL, which is equal to the load impedance over the characteristic impedance. So ZL equal to 15 plus J30 over 50, and it's equal to 0.3 plus J.6. Now we have to select the normalized impedance on Smith chart using Kitab software. First of all, we have to import the impedance Smith chart. Here's the impedance Smith chart. Now we can control the zoom just from right here, so we have to zoom it first, then take the pen from here, change the color. Okay, now here's 0.3 and we want 0.3 plus J.6. Here's 0.3 and here's our point, the normalized impedance. Okay, normalized impedance. I'm going to minimize it just right here. Okay, here's the normalized impedance. Now to do the matching network, we have to move it from the normalized impedance reaching to the origin. To do that, we have to move in a constant resistance circle first, then a constant conductance circle, or to move in the constant conductance circle at the first, then on a constant resistance circle to reach the origin of the gamma S plane. On my example, I'm going to move in a constant resistance circle at the first, reaching to the intersection point of a circle that is going to lead me to the origin of gamma S plane. Note that we are moving on a constant resistance circle at the first in the direction of anti-clockwise, so we are going to add a series capacitor. Then I moved on a constant conductance circle in a direction of a clockwise, so I'm going to add a parallel capacitor. And also we have to be concerned about the intersection point between the constant resistance circle and the constant conductance circle. So back to the question. 1. The intersection point between the constant resistance circle and the constant conductance circle is denoted by ZB, and it's equal to, back to Smith chart, here we have ZB, and it's equal to 0.3 plus J point, let me see, here's my intersection point, so it's 0.3, and it's, let me see, we have to move right here, so it's almost to 0.44. Okay, so ZB is 0.3 plus J 0.44. 2, we moved on a constant resistance circle in the direction of anti-clockwise, so we are going to add a series capacitor, and its value will be found by doing the following. ZC, which is the capacitor value, equal to ZB minus ZL, which is the normalized impedance, which is equal to 0.3 plus G 0.44 minus 0.3 plus J 0.6, which is equal to 0.2, I guess it is equal to 0.16. 3, we moved on a constant conductance circle in the direction of clockwise, so we are going to add a parallel capacitor, and its value will be found by doing the following. Here you have to be concerned about the following. A, since we moved on a constant conductance circle, then we are dealing with an admittance. So first of all we have to divide ZB, we have to divide 1 over ZB, which is 1 over 0.3 plus J 0.44, 0.3 plus J 0.44, and I suppose it's equal to minus 1 over, which is equal to, I'm going to take more spaces, 1 over 0.3, okay, which is equal to minus J 1.55 minus J 1.55. So right now, which is equal, I'm really sorry, 1 plus 1 minus J 1.55. B ZC2, which is the second capacitor, the second actually parallel capacitor, is equal to the following, which is the origin ZO minus ZB, and this is going to give us 1 plus J0, since we are at the origin, J0 minus 1 minus J 1.55, and this is equal to plus J 1.55. So the answer is 1, a parallel or a series capacitor, with the value of minus J 0.16. Actually we have to correct right here, which is minus J 0.16, and a series capacitor with a value of minus J 1.6 into a parallel, so for that, to a parallel capacitor with a value of J 1.55. So back to Smith chart to draw the matching network. So the matching network will be, here we have, suppose here we have ZL, and first of all we say that we have a series capacitor, so this is C, and then we have a parallel capacitor, which is just right here. So this is the matching network that we really have, and this is C1. Thank you, and I hope this video is going to be useful for you guys.